So we'll start today.
Anyone unmute yourself and tell me the screen is visible and audible? Lenin?
Yes, sir.
Okay. Only 10 students were present for the class. ನಂದು ಮೊಬೈಲ್ ನೆಟ್ last class we discussed about the transducers. Transducer is the instrument or the system which receives the signal from the primary stage. From that stage receives the signal and transduces the word. Remember the word transducer. Transducer means transduces the signal received from the input. Then it is converted, filtered, amplified, and fed to the next stage. That can be studied by using this block diagram. All of observe here primary transducer and the secondary transducer. The primary transducer receives the input, amplifies, rectifies, filters, and many more translations takes place in the primary transducer and then which is converted into analogous signal. Then analogous signal is converted and fed to the secondary transducer, where the secondary transducer receives the analogous signal, convert that into voltage signal. Again, that voltage signal is converted into digital signal or digital form. So that is the result of the measurement. For this good example is speedometer of the vehicle or measurement of resistance or measurement of current by using multimeter. So this is a very good example for primary transducer and the secondary transducer. That is the measurement of resistance, a measurement of current, or the speed of the vehicle, or the measurement of the speed of the motor by using tachometer. Next, come to the point. The transducers are classified into mechanical transducer, electrical transducer, and electronic transducer. The mechanical transducer is dial indicator. All of you seen the dial indicator, which we use in the metrology lab for the measurement of taper and other measurement. So, in the electrical transducer, this is very important. Usually, this electrical transducer is a linear variable differential transformer, which we use in the lathe for the movement of the carriage after reaching the tile stock end. So, change of direction of the movement of the carriage in the lathe, usually linear variable differential transformer switch is used for change in the direction of movement of the carriage. And also, all of you see the lift. See, the lift moves upward direction and downward direction. So there also they use linear variable differential transformer for changing the direction of movement of the unit. That you can call it as a carriage or the room, so which we use it for moving the upward and downward direction. Next, come to the point, the electronic transducer. All of you observe here, this is the instrument used for measurement of roughness of the surface plate made of cast iron or made of granite. So all of you seen the granite slab. So that is used for conducting the experiment on the granite slab in the metrology lab and in the machine shop or in the workshop for marking of the workpieces. Marking, this is very, very important. Marking of workpieces, we have to keep the component on the surface plate so that you can easily mark the component. See, what are the things present here? There will be a plunger, and again, this plunger is connected to a flexible diaphragm. The flexible diaphragm is usually made of a flexible material, so that you have seen in the speaker. The same type of material used for flexible diaphragm. And again, diaphragm is connected to the coil, which is made of tungsten. This coil is again, there will be two plates which moves upward and downward direction due to the displacement of the plunger. So due to this movement, there will be change in the electrical characteristics that can be measured through this rod. Rod is connected to the terminals. So this terminal is connected to milliammeter or millivoltmeter. So due to the displacement of this plunger, there will be change in the position of the plate, which alters the characteristics of electrical current, so that that can be measured through milliammeter. So this is the electronic transducer used for measurement of surface roughness. Surface roughness. Next, come to the point. Very, very important. All of you write down the topic, generalized description of a measuring system. Generalized description of a measuring system. Mark it, very, very important. This time you can expect this question in the examination for 10 marks. In the module 4, second portion of the module 4, you have a question. Explain briefly with the block diagram, generalized description of a measuring system. First, for example, what is the measured medium? See, suppose if I ask you to measure the speed of the vehicle or speed of the motor or speed of the turbine or the temperature of the oil and measured quantity, that quantity, if it is temperature, that is in degree centigrade, if it is speed, that is RPM, if it is current, that is in amperes. So measured quantity is according to the type of medium, measured medium and the measured quantity. And the first block is a primary sensing stage or primary sensing element. Next, whichever the signal received by the primary sensing element, which receives the signal and translate the signal and fed to the variable conversion element. Remember the word variable. So you can add or delete or some of the contents of the input and vary the input that is coming from the primary sensing stage, that will be amplified, rectified, and again that is fed to the third stage, variable manipulation element. Word variable manipulation. Suppose you need only the speed, rotation of the shaft or the rotation of the motor shaft or the turbine shaft, that is only the rotation is required, other things are not required. So only the rotation of the shaft that manipulates, that is in RPM, that is in RPM, which is fed to the auto transmission element. Suppose you have digital indicator for presentation of speed of the turbine or speed of the compressor or speed of the motor. Auto transmission element receives the signal from the variable manipulation element that is amplified, rectified, and converted into voltage signal. In variable manipulation element, the signal coming from the variable conversion element, which is converted into analogous signal. Remember, in the variable manipulation element, that the signal coming from the variable conversion element, that is amplified into analogous signal. Analogous signal. So here in the transmission element in the fourth stage, whichever the signal received from the variable manipulation element, that analogous signal is converted into voltage signal, and voltage signal, that voltage signal is converted into digital signal or digital form that is fed to the data presentation element. So this data presentation element receives the signal in the form of digital input that's converted into the form that can be interpreted by the observer, that can be interpreted by the observer, and this is the presented data. Suppose if you are measuring the speed of the shaft, the presented data is in RPM, that is in 1200 RPM. Suppose if you are measuring temperature, that's in degree centigrade. See, the observer can understand the output coming from the data presentation element that converts the voltage signal, that converts a voltage signal into digital signal, and digital signal is converted into the digital form that is understood by the observer, the presented data in the form of presented data in the form of, if it is speed, that is in RPM. Then if it is temperature, that is in degree centigrade. If it is pressure, that is in kg per millimeter square. See, all of you, please write down the question. Explain briefly. Unmute yourself. Hello. Unmute yourself.
ವಿಡಿಯೋ ಕಾಲ್ ಮಾಡು ಹಂಗೆ ತೋರ್ಸು ಹಂಗೆ ಕಟ್ ಮಾಡ್ಕೊಂತೀರಾ
Please write down the question. Explain briefly with block diagram.
ವಿಡಿಯೋ ಕಾಲ್ ಮಾಡಿ ತೋರಿಸ್ತೀನಿ
Hello, who is there speaking? Unmute yourself. Explain briefly with block diagram, generalized description of a measuring system. Ritik, unmute yourself. Ritik.
Sir.
Ritik came. So you have two identities.
Yes, sir.
One is 60. Two times you have. Yes, Ritik.
Sir,
All of you unmute yourself and tell me the answer. I'll call your name.
cut mara.
Unmute yourself. All of you unmute yourself. Answer your roll call.
ಆಮೇಲೆ ಮಾಡ್ತೀನಿ ಇರೋ ಮೇಲೋಗಿ.
Ritik, you have entered twice in different mobile phones. Ritik, you have logged twice in different mobile numbers. All of you unmute yourself. Answer your roll call. All of you unmute yourself and answer roll call.
ಹೇಳಿ ಸರ್.
Kavish. Kavish.
Yes, sir.
Prithvi.
ಆಮೇಲೆ
Sir, present, sir.
Aman.
Present, sir.
Tell me your name. Hello, tell me your name. Kavish.
Yes, sir. Present, sir.
Prithvi. Aman S.
Sir, Prithvi, I am present, sir.
Okay. Chamant. Vinayak J. Hadriali. Vinayak N.
Present, sir.
Yashwant.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Yashwant KR.
Present, sir.
Nikhil Gowda. Nitin GS.
Present,
Nitin
sir.
GS.
Present, sir.
Okay. Nitin LM.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Pawan H. Pawan H. Pawan Kumar GV. Pawan MC.
Present, sir.
Pawan T. Pawan T. Prajwal. Prajwal. Pratham P. Pratham P.
ಸರ್.
Pratham present. Tell me your name. All of you unmute yourself. All of you unmute yourself in your mobile. Prajwal Chaudhary, Pratik T, Pratham D,
Present, sir.
Pritam
Hello.
D,
Present, sir.
Pritam D present. Yes.
Present, sir. Yes, sir. Present.
Raghavendra E, Raghavendra, Rahul MP, Rahul N,
Present, sir.
Rahul N present. Rajat GC, Rakshit GL, Rakshit R, Ranjan Kumar, Renil, Ritik M,
Yes, sir.
Mohammed Ittekar, Mohammed Ittekar, Talikula, Sambram,
Present, sir.
Sanjay.
Present.
Present. Sambram. Shashank. Shashank HS.
Present, sir.
Siddharth HR. Subodh. Sudeep. Sudeep MD. Suhas. Sumukh.
Yes, sir.
Sumukh present. Swarup. Swati. Syed. Mehtab. Vedashri.
Present, sir.
Vedavyas.
Present, sir.
Vineet. Vinay Patil. Yashwant S.
Present, sir.
Karthik. Okay, all of you, write down the question, explain briefly with the block diagram, generalized description of a measuring system. Here you have 5 elements. You have to use the 5 elements for any type of measurement, whether it may be temperature, whether it may be pressure or speed of the vehicle or running of the motor or speed of the shaft of the motor or turbine or anything. So these are the 5 basic elements are required for measuring system. Very, very important. All of you mentioned this is very, very important, and you can expect this question in the examination. Without this question, there is no question paper at all. See, please, all of you, write down very, very important. Next portion of your 4th module, intermediate modifying system. So we discussed the generalized description of measuring system. In that, there will be an intermediate modifying element. All of you seen. The 3rd stage of measurement is the intermediate modifying system. So this intermediate modifying system receives the signal from the primary stage and amplifies, rectifies, filters, and develops the signal and fed it to the final stage. The final stage, you are measuring the temperature or pressure or current or anything. So that is intermediate. The name itself indicates intermediate modifying system. That is, the name itself says intermediate, which receives the signal from the primary stage and it modifies, amplifies the signal, that is, converts the input signal into the voltage signal or analogous signal, that is converted into voltage signal, and again that will be converted into the digital signal or digital form. This is a very, very important for measurement, that is intermediate modifying system. Here, the input signal that is coming from the primary stage, it is amplified, rectified, and converted into analogous signal. Again, that analogous signal is converted into voltage signal. The name itself indicates intermediate modifying system. That is Usually, all of you have seen the power steering in the car. Power steering in the car. Next, the shock absorber. Shock absorber in the two-wheeler. And the rack and pinion arrangement in the dial indicator. Rack and pinion arrangement in the dial indicator. So that is the intermediate modifying system receives the signal, and which intermediate modifying system improves the signal, converts the signal, or amplifies the signal that can be fed to the final stage. In the final stage, you are going to measure if it is temperature, that is in degree centigrade, if it is pressure, that is in kg per millimeter square, suppose that is in speed, that is in kilometer per hour of the vehicle, or sometimes that is the dynamic signal. What we can say, the input signal receives the intermediate modifying system, which that signal is amplified, converted, and again sent to the third stage or final stage where you are measuring the system. If it is a temperature, it is in degree centigrade. If it is pressure, that is in kg per millimeter square. If it is speed, that is in RPM. That is the mechanical system, or usually rack and pinion arrangement, or gear system, or the hydraulic system. Then the input signal is improved or amplified to the higher level that can be fed to the final stage where you are going to measure the system. That is the that is nothing but the output. See, in the mechanical system, you have little problem while converting the input signal into the signal which is accepted by the final stage. So there will be some problems are always present in the mechanical system, that is kinematic linearity. The name itself says kinematic linearity, that is called mechanical advantage. That is called mechanical advantage or gain. That kinematic linearity can be defined as, that's again, that is in ratio of input to the output, that is input displacement to the output displacement, again which is defined as the kinematic linearity or mechanical advantage or gain, defined as which is the ratio of input velocity to the output velocity. Remember, mechanical gain, say the small amount of input which is increased to higher level. See, 10 units increase to 100 units, or 10 units is increased to 1000 units. That is mechanical advantage. Small movement of the shaft which is converted into very high movement of the shaft by using gear train or using the amplification, hydraulic amplification, or any type of amplification. See, the mechanical advantage or mechanical gain. The input is 10, the output is 1000. So that is the mechanical gain. That is the kinematic linearity. The mechanical advantage or gain can be defined as, that is input, ratio of input to the output, whether it may be displacement, whether it may be velocity, or whether it may be RPM, whether it may be movement, that can be amplified. The mechanical gain, for example, 10 RPM, it is increased to 1000 RPM. Imagine the 100 tons that is increased. That is called mechanical gain. That is that of definition of mechanical gain, which is the ratio of input to the output, whether it may be displacement or velocity or speed or the linear movement. The 10 millimeter increase to 1000 millimeter, or 10 RPM increase to 1000 RPM. That is called mechanical advantage. Next, while measuring the mechanical gain, you have little problem in the gearing system or spring system or in the system itself. That is the problem in frictional loss, inertial loss that always arises in the system, that is called reflected inertial amplification. Say the 10 RPM is increased to 1000 RPM. In that case, there will be little inertial amplification was lost due to the improvement of the signal. So that can be called as reflected inertial amplification. Next, come to the point, temperature problem. As I told you earlier, the due to temperature, if it is very high temperature or if it is a very low temperature in the instrument, there will be thermal contraction or thermal expansion due to always in the metal. Say, remember in your lifetime, in all the metals, there will be thermal contraction and thermal expansion. Due to these mechanical properties, you will not get the accurate result. So, for that reason, the temperature problem always arises in the mechanical measurement. That is called temperature problem. Always a temperature problem is present in mechanical system and electrical system. So for that reason, you add some of the alloys to the measuring instrument that is made of metal. So usually the metals are used in the measuring system are copper or silver alloy or copper alloy. If you add silica or carbon to the copper, so that you can avoid the temperature problem. Say in some of the instruments, you will not get an exact zero reading. Without input, no input to the system, you have a little shift in the needle. Suppose if you are measuring pressure in the pressure gauge, the needle is always on the above or after the 0 point. So that is called zero shift. So it neglect that zero shift while conducting the measurement. While conducting the measurement, say in the temperature problem. So due to thermal expansion or thermal contraction of the metal used in the measuring system, which affect the output of the system. So the temperature problem always present in the mechanical system. And in some of the instruments, always you have zero shift. That is, you don't have the exact zero reading or null balance. Suppose if you provide no input to the system, also there will be little movement of the needle in the system that is present. So for that reason, that is called zero shift. And next come to the point, scale error. Scale error. For example, consider the 0 to 1, 0 to 10 pressure indicator. That's the pressure gauge which indicates the pressure from 0 to 10 kg per millimeter square. So then the pressure of the air compressor of the air tank is 4, but the needle shows 4.1 or 3.9. So that is called scale error. That is called scale error. You need 4, but the indicator of the dial of the pointer shows 3.9 or 4.01. That is the scale error. Scale error. So this much is enough for this class. So that is intermediate modifying system. So here the intermediate modifying system means which receives the signal from the primary stage. That signal is improved, amplified, rectified, and fed to the final stage. Then the final stage presents the data that is in the form of, if it is temperature, that is in degree centigrade; if it is pressure, that is in degree; if it is pressure, that is in kg per millimeter square; if it is speed of the turbine, that is in RPM. Next, come to the point, the mechanical system. So the good example for mechanical system, intermediate modifying system, is the linkages or gear system or gearing, gear train or spring. See, for example, 10 rotation of the shaft amplified into 1000 RPM. 10 RPM is amplified into 1000 RPM. For that, you can use the gearbox or gearing system, improve the rotation of the shaft into 1000 times. That is 10 into 10, 10 into 1000, or 10 into 100. The improve of the signal that is received from the primary stage, that is amplified, improved, and rectified, and which is amplified. 10 RPM increase to 1000 RPM. This is a good example that is used in gear system of the vehicle. See, small rotation of the shaft, which is increased by 1000 times. That is the mechanical system. See, in mechanical system, there will be a lot of problem arises in intermediate modifying system. That is one, kinematic linearity. Kinematic linearity is nothing but the mechanical advantage or mechanical gain. The mechanical gain can be defined as, which is the ratio of input to the output, whether it is RPM, whether it is displacement, or whether it is velocity. That is the ratio of input to the output. So all of you observe here, mechanical gain or advantage equal to output divided by input, or output divided by input. That you can define like this, the ratio of input to the output. Next, come to the point, sometimes there will be reflected inertial amplification is present. Say, while conducting the improving the input signal, there will be some inertia is present in the system, that is called reflected inertial amplification. Next, temperature problem. Say, in the measuring system, always metallic parts are present. The components are made of metal. The metal exposes to the higher temperature or lower temperature. There will be always thermal contraction due to the mechanical property of thermal expansion and thermal contraction. Then the system will not present the accurate result. So the temperature problem must be eliminated. For that reason, the mechanical system have copper, silver. For that, you can add silica and carbon to the metal so that you can avoid the temperature problem. Up to 95%, you can avoid the thermal contraction or thermal expansion of the metals. Then come to the point to zero shift. See, all of you seen the pressure gauges used in air compressor. For example, the gauge shows the pressure from 0 to 10. So the pressure of the tank is 4, but in the pressure gauge, which shows 3.9 or 4.1. So that you require 4, but it shows the 3.9 or 4.1. So that the needle movement of 3.99, 3.9 or 4.1, it is called zero shift. Zero shift. So this type of problem always arises in the mechanical system. So that you have to avoid. There will be an adjustment in the backside of the pressure gauge. From that, you can adjust the zero shift so that you can read null balance. That is, for no input, then no output. So that's called zero shift. Next, the scale error. So that is Sometimes the same needle reads instead of reading 5, it reads 5.1 or 5.2 or 4.99. That is the scale error. So next class, I'll continue. Now, all of you, please enter your name and USN in the chat box. This much is enough for this class, and I will continue in the next class. All of you, please enter your name and USN in the chat box.